Okay, let's start with the square root of x. This is the original. Remember that you can kind of manipulate this, making it move left or right, up and down. Let's talk about the domain and the range. So the domain and the range have restrictions when it comes to this specific graph. So the domain in this one, there are limits to x. X cannot be negative. So it is x is going to be greater than or equal to 0. Same thing with the range. The range, y is greater than or equal to 0. All right? Now let's see how you could manipulate this shape. So if I were to show you this one here, right? And I asked you to graph this. Now it's the same exact graph, but I've moved it to the left 2 and down 1. Remember, inside of the parentheses, in this case, the radical is the parentheses. Inside the parentheses, it controls the opposite of what you think. So this is going to be left 2 and down 1. So this point right here is now where that point is. So now you just make the same arch you just did, and it's graphed. Okay, the domain for this one has changed. The domain has gone all the way to -1, or all the way to -2. So x is greater than -2. And then the range goes up to -1. So y is greater than or equal to -1. And there we go. Domain and range of those. All right, so let's do these now. Now this one, x to the third power, I like to call Superman. He looks like he's posing. Okay, so this is the Superman. If I were to do this, I would have moved it to the left 1 and down 2. So left 1 and down 2. So this is where it has to change directions like it did here. So now I'll do something like, and there we go. Forever that way, forever that way. Okay, for these, the domain and the range are for all real numbers. There's no restrictions to up and down, and there's no restrictions to left and right. All right, now let's talk about this. So this is the cube root of x. So the cube root makes an s, like that. Now if I were to do this, I would have moved it to the right 1 and down 2. So to the right 1 and down 2. So here is where the s has to change directions. So here we go. Let me hold this down a little bit more, and there we go. Man, this pen is pretty rough here. Okay. Now let's go over the 7 types of graph and just a couple of information about each one. Okay, I know there's a lot of questions we go over. So what we're going to be going over here is domain and range. Actually, I've already done those. So let's check those off. Domain, range, then we're going to be talking about the minimum, the maximum, the increasing, the decreasing, the positive, negative, and end behavior. It's a lot of information. So every question I'll try to talk a couple of them. Okay, maybe 2 and then 2 and then back it up and do 2 and so on and so forth. Okay, so for this one, y equals x is a straight line. The domain and the range are continuous. There's no restrictions. The minimum and maximum, there is no minimum and maximum. It is increasing forever and it's not decreasing at all in this situation. And then the positive and negative, it's positive after 0 and it's negative before 0. And then the end behavior is it is increasing forever in this direction and decreasing forever in that direction. All right, absolute value of x, that makes this fancy v here. Okay, this has restrictions to the range but not to the domain. There is a minimum. There is no maximum. It is increasing in this direction and decreasing in that direction. So it's decreasing until it gets to 0 and then increasing. So you'd write something like that. Like you'd write for the increasing and decreasing, you'd write decreasing from as long as it's less than 0. So when x is less than 0. And it's increasing when x is greater than 0. All right. This one here, this is exponential growth. So it looks something like this. All right. This one here, this is exponential decay. So it looks like this. All right. And then here we have a quadratic. So it looks like a U. Again, restrictions in the range, not in the domain. This one's going to have a restriction in the domain. We already talked about that. It looks like that. We already talked about this one. A little Superman action. Don't know why my pen just stopped writing. And then the last one here, which I didn't write a graph for, is the S. So for all these graphs, when you're describing the minimum and the maximum, it needs to be a coordinate. If you're describing the increasing and decreasing, you're describing it using x as its location. Okay? When is this increasing? It's increasing when it's greater than 0. When is this one increasing? When it's greater than 0. Okay? When is this one decreasing? When it's less than 0. Okay? Actually, it's increasing and then increasing. So this is continuously increasing and not decreasing at all. This one's the same thing, increasing constantly. Okay? The information here is not difficult to find. You just have to know how to name it. End behavior, remember, you're telling me what's happening after it leaves the graph. Okay, so is it increasing forever or is it decreasing forever? It depends. And that's it.